Hey guys, somebody had asked me to do a few of the problems from the review packet, so I'll go ahead and just do them. And if you have any other questions, you can certainly let me know. So the first question was about number 9, and the thing about number 9 is you got to realize that this angle here, the 4x minus 7, is on the outside of the triangle. Okay, if it was in the inside, if it was right here, then yeah, you could do the old-fashioned this one, and this one together make the 180. But as soon as you get one on the outside, you have to use a different theorem. Since this is called an exterior angle, we're going to use our exterior angle theorem. This was from section 4.1, which in your notes you should have the actual theorem and all the examples that we did. And the theorem basically said that the exterior angle is always equal to the sum of the two angles on the inside that the exterior angle is not next to or not adjacent to. So this is the angle it's adjacent to. We want the two other ones. If we knew this one, we could, do all sorts of things. We could do supplementary for the linear pair. We could do, the 180 for the, inside of the triangle. But they purposefully left this one out, so we were forced to use this new theorem. Or not new theorem, but the theorem we learned. So 4x minus 7 equals x plus 110. So these two together is the same as this one. All right? So if I subtract x from both sides, the rest should be pretty straightforward. Add 7 to both sides, and then figure out that, what is that, 39? And there you go. Okay, so the key is to recognize this as an exterior angle and not to fall into the trap of all three of these add up to 180. Okay, so that's from section 4.1. You can look that up if you need more practice with that. One of the other questions was number 13. So for this one, I said, hint, you may want to draw a picture. I definitely recommend drawing a picture whenever possible. They're telling you triangle LMN is isosceles, where LM and LN are the ones that are the same, the legs that are the same. So LM and LN. So it's going to be LMN, and I'm going to draw it like this. LM congruent to LN. Now you can pretty much draw it any way you want as long as LM and LN are the same. So that's why I put the tick marks in the right spots for that picture. They're telling you LM is 3x minus 2, 3x minus 2. LN is 2x plus 1. And MN is 5x minus 2. Now, if you look at this really quickly and you don't draw a picture, you might be tempted to just do this plus this equals 180. But these aren't angles, right? These are distances. This is LM. The distance from L to M is 3x minus 2. Notice there's no degree symbol, right? In number 9, look at number 9 again. Number 9, these are all degrees, right? So those are angles. They're clearly in the angle location. Whereas in number 13, they're telling you these are specifically distances. So I'm not going to do anything with 180 degrees because I don't care about the angles for this one. I just need to figure out how to solve for x based on what they gave me. So now because this is isosceles and I know these two segments are congruent, I know this piece must equal this piece. These two lengths must be the same. So you might ask, well, what about, the 5x minus 2? Well, unfortunately, that one's not really going to help us for this problem. So I'm just going to use the two that actually match up. 3x minus 2 must equal 2x plus 1. And the 5x minus 2 is just there as probably a distractor. Okay? I'm guessing some of you probably would do all of them add up to 180, which I said before you can't do. And some of you might have matched up the wrong ones. Okay, notice this, it didn't say that this triangle is equilateral. So you can't just assume they're all the same. You have to only go with what you've got. So in this case, if you solve it, it looks like x equals 3. If x equals 3, this would be what? 7. This would be 9 minus 2 is 7. And this would be 15 minus 2, which is 13, which I wouldn't expect to be the same. Okay, it could have been, but I didn't know that for sure. All right, so that's one like that. This was, technically, I guess this would be in 4.7 because it involves isosceles triangles and their lengths. So if you're looking this one up, it's from 4.7. Same thing with this one. This would be from 4.7. This time, they don't tell you what type of triangle they have. You got to kind of figure that out yourself. I would hope that seeing these 60-degree angles that are the same might trigger something for you. First of all, if these two angles are the same, you know instantly these two sides are the same. Right? That's our base angles converse. But more than that, because these are actually 60, we can figure out what this one is, left over. If these are each 60, how much is left over to get this one? Well, it just so happens it's also 60. So all three angles are the same. If all three angles are the same, all three sides are the same. If it's equiangular, it's equilateral. If it's equilateral and one of the sides is 8, I guess both the other sides are 8. and we just found the length of WX. All right, so you really want to look for what type of triangle you're dealing with, where do the tick marks go, and how does that help you in solving whatever it is they want you to solve. All right, I hope that helps. If you have any other questions, don't hesitate to ask, and I will talk to you guys later. See ya.